starting off today's lesson, we're going to start with these vocabulary words. I'm also going to give you like visual representations for what they mean as well. So concurrent lines are three lines that intersect at one point. So up until now, you're pretty familiar with intersecting lines. That's where two lines intersect, and then this is where they intersect right here. Concurrent lines are three lines that intersect at one point. So these are concurrent lines. And then where they intersect is called the point of concurrency, right there. So this intersection point in some triangles creates some like relationships and like equal parts and segments. The circumcenter is the first one we're going to focus on. It's where three perpendicular bisectors intersect in a triangle. So up here, this diagram right here, we're going to highlight and kind of label this. So a perpendicular bisector, so one of the perpendicular bisectors right here, segment PD, this segment is perpendicular to the side of the triangle, and also because it's a bisector, it breaks this line up into equal parts. So this is the same length as this over here. So that is a perpendicular bisector right there. And then over here, we have a perpendicular bisector for this segment here, creates a 90-degree angle, and then because it's a bisector, it breaks it up into two equal parts, so this part of the segment is the same length as this. And then here, this segment right here, if you don't have like three colors, it's okay. It'll be all right. This is a perpendicular bisector here, and it breaks this segment up into two equal parts here. And then where these perpendicular bisectors intersect is called the circumcenter. Circumcenter is where those perpendicular bisectors intersect. So as you can see in this diagram, these perpendicular bisectors aren't the same length. They're different lengths, but they are lines that break up these sides into two equal parts. But what happens is when you have those perpendicular bisectors, I'm going to use a pen now, this circumcenter is the same distance from each of the corners. So the length from the circumcenter to this corner is the same as the length from the circumcenter to this corner, and then the same length from the circumcenter to this corner. So if you're trying to find the middle of like 3 points, it would be the circumcenter. And then so this length is the same as this and the same as this. So a lot of equal parts. Okay, so that is circumcenter. Then the second one we're going to look at today, do you have that all down, is incenter. So in your vocabulary, the incenter is where three angle bisectors intersect. So I'm going to highlight the angle bisectors in blue. So this right here is an angle bisector. It breaks this angle A up into two equal parts. So this is the same length as this over here. Pen to show that. And then this right here is an angle bisector of angle B. So this side of the angle is the same measure as this side of the angle. And then angle bisector for angle C right here. And this side of the angle is the same side as this side. And where these three angle bisectors intersect is called the incenter. Okay, and then as a result of this, where the angle bisectors intersect, then the length from this incenter to the sides is all the same. So the three lines that are highlighted in yellow are all the same length. So this equals this equals this. And it shows it perpendicular because that would be the shortest length to the side. Okay, so now we're going to look at the math involved in this. As you can see, there's equal parts, so we're just going to be putting stuff equal. So now we're going to turn to the practice problem. So I'm going to have you turn to 6.2. Okay, I'm going to zoom in. 6.2 practice right here. It says, in exercise 1 and 2, the perpendicular bisectors of ABC intersect at point G. Find the indicated measure. So perpendicular bisectors intersect at the circumcenter. Just going to make a note. And so for these, I'm going to use blue for the perpendicular bisectors, and then the equal parts will be in yellow. So if you want to kind of use that pattern, you can. Or do you want me to use pink and yellow? I got pink, yellow, or blue. What do you think? Pink is better? Okay. So, yes. Pink will be the perpendicular bisectors, and then yellow will be the equal parts. So yellow are equal parts. Okay. So, perpendicular bisectors here. This right here is perpendicular to the side, and it bisects those two segments into equal parts. And then this is a perpendicular bisector, and then so is this. Perpendicular meaning it makes that 90-degree angle, and it breaks these into equal parts. Okay, and then when you have that circumcenter right there, it is the same distance from all the angles, or all the points or corners, vertices. So then my yellow parts, this equals this over here, and this equals this. However you want to label that. Okay, it's asking for the length of BG. So all our yellow parts are equal, so I'm looking for the yellow to be labeled, and it's labeled right here, AG is 9, so therefore BG is also 9, and that's our answer. Okay, and then number 2 right here. Number 2, they had to kind of draw it outside the triangle because it didn't fit on the inside. But same thing, I'm going to look for those perpendicular bisectors. Oh yeah, I'm using pink. So perpendicular bisector right here. Okay, so there's one perpendicular bisector. It's perpendicular to this segment, and it forms that 90-degree angle. This right here forms that 90-degree angle. And then behind GF is also a perpendicular bisector right there. And then point G is that circumcenter. Yes, I'm challenging your brain right now. Then from the circumcenter, it is the same distance to all the corners of the triangle. So this length is the same as this length, and the same as this length. So all the yellows are equal. And so it's asking for the length of GA, which is the same as all the other yellows. So GC is 11, so GA then must be 11 as well. Yes. Oh. Did you get one on Monday? Because I don't have one with anyone, meaning you were here on Monday, right? And you got one. Okay. Okay. So the next ones, it says modeling in real life. You and two friends plan to walk your dog together. You want the meeting place to be the same distance from each person's residence. Explain how you can use a diagram to locate the meeting place. Okay, so we got 3 points. We want the meeting place to be the same like walking distance between these 3 places, so we'll draw a triangle. Okay, so what we're going to do is we're going to draw perpendicular bisectors of each segment. So I'm going to just eyeball the middle and draw like a line that's perpendicular to that. Eyeball the middle of this segment and draw a line that's perpendicular. And then eyeball the middle of this segment, draw a line that's perpendicular. I don't know. Okay, so yeah, not the best drawing, but that's the idea. And then from there, so this would be my pink, the perpendicular bisectors. Then this circumcenter should be the same distance to all the corners. So this distance, and this distance should be all the same. Okay, number 4, same thing. It says you open a donation center the same distance from each of the 3 stores shown. Use a diagram to determine the location of the donation center. So just starting by drawing that triangle. Let's see. Then I'm going to try to draw a perpendicular bisector of each of the segments. I'm just eyeballing it, so it might not be perfect. That's cool. And it goes to this point. So these lines would be the pink. And then from here, drawing a line to each of those corners, this will all be the same distance. Next, this is similar to the first 2, but now it's asking about angle bisectors. So angle bisectors intersect at the incenter. So now we're doing the incenter. So with the colors, I'm going to use blue now, or you can use whatever other color you have if you have another color. I'm going to highlight the angle bisectors. So this right here is an angle bisector. It bisects angle X. This bisects angle Y, and this bisects angle Z, and they intersect at the incenter. So angle bisectors are blue. And just like before, the yellows are all going to be equal. Okay, and then the incenter is the same distance from the sides. So these segments are going to be all equal. This equals this equals this. It asks for the length of PB. It looks like it's labeled 15, but 15 is a label for the blue right there. So PB is actually 9, the same length as this yellow over here. Some of the ones on Alex, I notice sometimes you have to solve for the right triangle here. So you might have to use Pythagorean theorem once in a while to solve for a side. Just FYI. But there's none like that in this practice. Okay, HP here. So again, your angle bisectors, I'm highlighting in blue all the angle bisectors. They intersect at the incenter. And then the incenter is the same distance from each of the sides. So HP, which is one of the yellow segments, is going to be the same as PK, which is 15. Okay, the next ones are graphing. We're just going to cross it out. Our brains don't have room for graphing right now. Then we're going to move over to the other page. And we're just going to do 2 on the other page, so we're almost done. Okay, so over here, we're going to do actually 11 and 13. So 11 right here, it says point N is the incenter. Incenter is where the angle bisectors intersect. So I'm going to highlight the angle bisectors. Then you have the incenter right here, and then that incenter is the same length to each of the sides. So all of our yellows again are equal. So this equals this equals this. Okay. It tells us that ND, which is one of the yellows, is equal to NE, which is another yellow. Or, well, it gives us an expression for both. Since they're both yellow, they are equal. So 6x minus 2 equals 3x plus 7, and we can set them equal to solve for x. You get x equals 3. On your homework, x equals 3 would actually be in the answer bank, but it's not what it's looking for. It's looking for the length of NF, which is one of the yellow segments. It didn't give us an expression for NF, but since all the yellows are equal, we can solve for example ND, and then that answer will be the same as the length of NF. So ND is 6x minus 2, so I'll do 6 times 3 minus 2. ND is 16. Therefore, NF is 16 as well, which is what it's looking for. Then last one, 13. 13. Again, angle bisectors right here. They intersect at this point. And then this is the same distance from each of the segments. Then it gives us NK and NL, which are both yellow, which are equal. So we can set them equal to solve for x. I think that's 2x minus 2 equals negative x plus 10. Okay, and then solving for x. X equals 4. Oh, I didn't realize it wasn't on the screen. I'm moving it up. Okay. X equals 4. This is the last problem. You got this, guys? No, it gets like long. X equals 4. Then it wants to know NM, but all the yellows are equal, so I'm just going to choose one of them. 2 times 4, yeah, it comes out to 6. Good job. Then K equals 6, therefore NM equals 6, and that is our answer. Okay, and that is all. So, at this point, you can start your homework on Schoology. Just take a laptop to your desk. If you have questions, please raise your hand so I can help you. If you finish the homework, which a lot of you probably will, then jump onto Alex and work on that.